Pointers can be a very daunting topic for computer science students of all levels, especially those that don't have much experience coding in languages that use them explicitly. In this situation, our language is C++. When I moved from CS courses that used Java to courses that used C++, all the principles and techniques I had learned transferred, but I was left trying to figure out how to use these little things called pointers to implement functions that previously I had no problem implementing in Java. This shock is real for CS students everywhere when they move from higher level and usually memory safe languages to lower level languages that aren't always memory safe. This is the trade-off for having more control over what the computer is doing. Hello everyone, my name is Carter. Today I'd like to make an effort to help you understand what a pointer is and what you can do with them. We'll start off with an overview of pointers and discuss what they are and how they're useful to us, then jump into a demo of what pointers will look like in your C++ code. Now let's talk about our first question. What the heck is a pointer? This answer is going to sound a lot more simple than it may feel right now, especially with how intimidating all the extra operators can seem when you're looking at code that uses pointers. I know myself that I can never remember when to use an asterisk versus an ampersand, but we'll talk more about that later. The answer to this question is simply, a pointer is a variable that stores a memory address. As the one writing the code, you have a lot of control over what this pointer points to. But fundamentally, it's the same regardless of what kind of object it may be pointing to. I like to think of it almost as an integer variable that stores some big long number corresponding to the location of something. Kind of like getting the longitude and latitude of a building and punching that into Google Earth. That address is your coordinate pair to find whatever you need. As you can see in the image on the right, you are able to access the value and address of variables. Addresses will usually have a whole bunch of seemingly random numbers and letters in them that correspond to a place in memory. It is important to understand that pointers are variables themselves and are subject to the same rules and limitations as every other variable for the most part. So while pointer variables have a value that stores an address of something else, they also have their own address that can be accessed. This makes it imperative to understand what the different address operators do to those values and addresses, which we are going to go over later. Now, looking back, this next question is pretty obvious, or the answer to this question is pretty obvious. Anyone that's spent any amount of time browsing Stack Overflow looking for any bit of code or information that might help with their C++ homework will know that sometimes you just have to use pointers. The biggest reason to use pointers is they allow you to perform this wonderful thing called passing by reference. In other languages like Java, you can pass by reference without really understanding what the differences between pass by reference and pass by value are. Passing by value refers to a function that takes a variable of some type as a parameter. This will let the function use a copy of the value of that parameter variable. This allows the function to use that value in its computation without changing the original value in any way. Passing by reference, on the other hand, refers to a function that takes an address variable, or a pointer, to a value of some type as a parameter. This allows the function to not only use that value in its computation, but also allows it to change the value stored at the passed address. This is especially useful when it comes to sorting or otherwise manipulating arrays and other similar data structures. Now, speaking of arrays, let's talk about another benefit of using pointers in your code: dynamic memory allocation. Dynamic memory allocation allows your program to request more space in memory for variables and objects that are created at runtime. This is where C++ and other similar languages become memory unsafe, as at that point, it's up to the one coding the program to make sure whatever memory is dynamically allocated is also released when it's no longer needed. Otherwise, your program can develop a memory leak and it'll slow down the system it's running on. Nobody wants to see that. Pointers can be used in dynamic memory allocation to reserve memory space for variables and objects as space is needed. This memory is located on the heap, completely separated from the stack where the memory is managed by the compiler and not dynamically managed by the one coding the program. It's very important to use this space because you have heaps more space on the heap than you do on the stack, in addition to the fact that it can be more easily reused as objects come and go. This is especially important when it comes to using arrays in your programs. Arrays and pointers go hand in hand when it comes to C++. As you might already know, arrays are essentially a space in memory where a bunch of one specific type of object are stored. When you access elements of an array and specify an index, the computer takes the address of the first element and calculates an offset that helps it to access the corresponding element based on its index. I'll be able to show this more in the demonstration part of this video. Now, knowing this, when you want the address of an array, for instance, to create a pointer for an array variable, what is that address going to be? The answer is that its address is the address of the first element of the array, or the memory address of index 0. This information probably isn't necessary to build your knowledge of pointers, but I digress. Arrays in C++ are mutable, which means we can change their values after we initialize them. This is important to know when passing arrays to functions. When you pass an array to a function, oftentimes you'll want to manipulate the elements of the array, which means we'll want to pass it by reference, in which case we need to make a pointer for our array object or pass the address of our array, right? The funny thing about that answer is this is one of the few times C++ is going to be nice and let us pass the array like any other variable, but with the added benefit of essentially passing it by reference. We can use the elements of the array and change them after passing an array to a function without the use of a dedicated pointer variable. This isn't how any old object will function when passing it as a function parameter, so arrays are the exception to pointers, not the rule. I'll go over this more in the demonstration part of this video. To me, the hardest part of using pointers in my code is the syntax of using these things. For a long time, I would just assume a pointer needed an asterisk with the variable type, but every once in a while you'd have an ampersand there for some reason. So if it didn't work the first time, I'd just swap whichever operator I had and just keep trying different things until finally it would work. Then I'd constantly get these errors about dereferencing a null pointer, and I'd get frustrated, screaming things like, I never referenced a null pointer in the first place, what are you talking about? You know, it's never fun to not know what an error is trying to tell you. So hopefully, I'll be able to shed some light on why those errors might be happening to you. Step 1 to understanding this is knowing the pointer-related operators. First is the ampersand. It is used before a variable when you want to assign a pointer variable to the address of an object or existing variable. Next is the asterisk. It is used to designate a variable as a pointer rather than a normal variable. It is also used when you want to access or change the value that is at the address a pointer points to. When you are assigning a pointer to an address, this is called referencing a pointer. When you access the value of a pointer, it is called dereferencing a pointer. This is where your dereferencing null pointer errors can occur. There's also a fun little arrow operator used with pointers to objects that have different class variables within them. This arrow allows you to access those fields and change them through a pointer to the object rather than a pointer to that data within the object. Having gone through all that, now it's time to show you what this will look like when you write your code. I've written this little demo here for us to go over the principles we've discussed so far. I'll provide a link to a paste bin with the commented code in the description of the video so you can look at it should you like to follow along. Alrighty, here is our pointers demo, C++ file. We're going to be going over some of the things we've talked about in a practical sense, what it'll look like in your code. I'm just going to go through this file from top to bottom. We'll go over the functions that we'll be using, and then we'll go through main and just kind of talk about what everything will do, and then I'll run it and kind of walk through just what we're printing to the console. The first thing of note is this macro up here. I just have a little macro int modifier equal to 8 right now. This can be changed, and it just changes what will be added to the integers we try to modify in these two functions down here. Not a super big thing, but it's something that if you're just kind of looking at the code, you might not know what this is doing. The first and probably most useful function to do with integers is this first one, reference modify int. It takes an integer pointer as a parameter and will add int modifier to the value stored at the address of the input integer pointer. This function will actually change the stored value, as we'll see later and as we talked about, and it uses the asterisk for both of these to specify that it is a pointer, and then down here when we dereference it to actually change the value. The second function is just modify int, and this is passing the same integer by value here. There's no asterisk, so it's just passing by value. And then we try the same thing down here, but since it's not a pointer that we're inputting, we can't actually dereference anything, so this is just gonna sit there and add 8 to the number, but it's only in the scope of the function. It doesn't actually return or anything like that, so it simply exists to do math and nothing else. We can't use it in any way. The next function is this mess up array that takes an int array of length 10, and this just goes through each index in the array and sets it to a random number from 0 to 100, random whole number, random integer. This we use to show how integer, not just integer arrays, but that's the example here. This would apply to other data types as well, that we can modify them without the need for a pointer, an explicit pointer, because all an array is just a bunch of memory. So accessing the array like this is essentially a pointer in the sense that it's still a memory address, but we don't have to specify it like we do up here with a non-array data type. And then we just have a print int array, little helper function that just goes through and outputs the elements of an input array. It's got to be length 10 though. No more, no less. Now we get down to our main function where everything's actually going to happen. The first thing we do is we're going to output what int modifier is, so you can check our computations later. And then we're going to we're just going to throw out an integer. I picked 5. Keep the number small, And then we'll create our first pointer. This pointer variable is called address x, and it will be pointing to the address of the variable we created up here. And we'll be able to check that with some outputs later. And this is where we use both operators with the asterisk to specify that this int variable is a pointer, and then we're grabbing the address, which happens to start with the same letter as ampersand does, of variable x. So we're setting address x to the address of variable x. Great. And then we're just going to output all of this, the value of x, and then the address of x, and then to double check, make sure we're doing everything right. We'll output the value of the pointer address x, and then the address of the pointer variable address x, just to show that those are two different things and that this is still a variable. It just doesn't store an int, it stores the address of an int. And then we'll modify the integer by passing by reference, in which case we'll just pass address x, which is the address of int x. And then we will output the same, more or less, values that we showed before to make sure it changed. And then we will run modify int, which just passes by value on x. And then we will double check again and show that nothing actually changed, because you can't change anything when you pass by value. And this is just a little demonstration of our dynamic memory allocation using an array when we're using the new keyword here to create a new integer array of length 10. And we're assigning that to a pointer because we're just, again, pointing to a space in memory that a bunch of ints will be. And then we just set the values of the array 1 through 10. And then we will show that we've created that int array, and then we'll print it out to the screen. And then, here's the fun part with int arrays, or just arrays in general. We'll show the address of the array, which in this situation, you just use the pointer here, because if we did put an ampersand before this, it would print a different address than we would expect, because this would be the address of the variable rather than the address of the array. So we leave that off in this case. And to show that this address is going to be the same as the address of the first index, we're going to print that, and then we will print the address of the last index of the array as well to show the range that these integers are stored in. And after printing all of that, we will randomize the array and print it out again. And then before our program closes, we will just delete the memory that we allocated for this, keep our program clean. So let's run that and take a look at our output. As we can see here in this output in the console, our int modifier is currently 8. The value of the variable x is 5, and its address is that wonderful number. And the value of the variable address x, which is our pointer, points to the exact same location in memory. Great. And then we show the address of the variable address x right there, which is completely different than the stored value. And then when we modify the integer through reference, the value of variable x, 13, which happens to be 5 plus 8. Great. Passing by reference works. And then, again, we just print out, the memory locations there. And then, now that x is 13, we're going to attempt to modify it through passing by value, which does nothing. Alright, so there you know to pass through reference if you want to change the value without needing to return anything. And finally, our array section, we can see the array 1 through 10 right there. The address and the address of index 0 are going to be the same thing. And the address of the last index of the array is going to be a similar looking address, but it's going to be further in memory. And then after we randomize the array, which is passing by reference again, but this time you don't have to specify it in the same way that we did passing an integer by reference, and then we get a randomized array there. I'll have this code posted on a paste bin or the GitHub equivalent. I haven't made up my mind on that yet. I'd like to take some time to thank you for watching, and I hope you have a great day. Thank you.